Just a couple of days ago, Kim Kardashian asked a question about Three-Eye Atlas and directed it to the acting administrator of NASA, Sean Duffy, and he immediately tweeted a reply in which he explained Three-Eye Atlas and so forth. But on the same day, Congresswoman Anna Paulina Luna sent a letter to Sean Duffy asking NASA to release this data that is being held for over a month. No response so far. When I approached the principal investigator of HiRISE, no response. It doesn't make much sense.
Harvard scientist Avi Loeb finally loses it after NASA ignores him for 32 days, but answers Kim Kardashian in less than 11 minutes. Something broke yesterday on November 2nd, 2025. Not physically, not in space, but you could hear it in Avi Loeb's voice during that interview. A fracture like a man who'd been patient for months, finally hitting a wall, and the reason might actually make you feel that way too. The interviewer asked about NASA, about the data, about why the highest resolution images ever taken of an interstellar object had been withheld for over a month. And Loeb, who usually measures every word, said something different this time. My complaint is more about the fact that there was an immediate response to her, but no response here. Her. Kim Kardashian. But why this obsession with NASA's October 2nd images? And why is that date so important for Three-Eye Atlas and this month of November? To understand, we need to go back 28 days earlier, October 2nd, 2025, the most important day in the entire Three-Eye Atlas story. Three-Eye Atlas passed within 30 million kilometers of Mars. When Hubble photographed this thing back in July, it was 450 million kilometers away. 15 times farther, NASA's Mars Reconnaissance Orbiter aimed its HiRISE camera at the object. The most powerful camera ever sent to another planet. 4 images were captured, and scientists from around the world had been waiting for this moment since July. Here's why those images matter more than anything else we have. First, the resolution. HiRISE achieved 30 kilometers per pixel. Hubble's best images were 100 kilometers per pixel. 3 times better resolution than the most famous space telescope ever built. To put that in perspective, where Hubble could see a city block, HiRISE could see individual buildings. Second, the viewing angle. This changes everything. When Hubble photographed Three-Eye Atlas, the object was moving almost directly toward Earth. We saw it edge on, like looking at a pencil pointing straight at your eye. You see the tip, not the length. That weird jet pointing toward the sun, we were looking at it compressed by perspective. Loeb did the geometry. Based on brightness and how the light scatters, that jet is actually 10 times longer than it is wide. But from our edge-on view, compressed by projection, it looked like maybe twice as long. From Mars on October 2nd, the view was completely different. Sideways, like looking at that pencil from the side. You see its full length, its actual structure, its geometry. That sideways view could reveal the actual 3-dimensional structure of the jet. Could show whether it's a chaotic natural plume of gas and dust expanding in all directions, or something with directed geometry, something with focused structure, something with design. Third, this is time sensitive in ways people don't understand. 3. Atlas is moving at 68 kilometers per second relative to the Sunday every single day. Gets farther from the sun, farther from Earth, farther from Mars. October 2nd was our one chance to get this view at this resolution from this angle. The object is leaving. It will never come back. This was it. Future observations depend completely on knowing what those images show, where to point telescopes, what wavelengths to use, what features to focus on. Whether to look for that debris cloud around the nucleus, or search for separated fragments, or track the jet's evolution, every single day those images are withheld. Other scientists around the world can't plan their observations properly, can't coordinate, can't maximize the rapidly closing window we have left. Fourth, multiple spacecraft were watching. The European Space Agency released their images within days. Lower resolution, but they released them, shared the data. NASA, total silence. The images exist right now on servers at the University of Arizona, processed, ready. Avi Loeb knew they were coming. He'd contacted the HiRISE team beforehand. October 3rd, he waited. October 10th, 1 week. He reached out to the principal investigator, no response. October 17th, 2 weeks. Loeb sent a formal letter to Sean Duffy. No response. October 24th, 3 weeks. He followed up. No response. 32 days of complete silence on the most important images we have. And then Kim Kardashian tweeted. And Sean Duffy responded in 11 minutes. That's what finally broke Avi Loeb. Because those October 2nd images could answer the question, what is this thing? July 1st, 2025, the discovery. Within days, Loeb does the calculations that will start a firestorm. He's not guessing, he's doing straightforward physics. Brightness plus distance equals size if it's reflecting sunlight. If that brightness comes from reflected sunlight off a solid rocky surface, the object is 20 kilometers across, Manhattan-sized. If Oumuamua were a ping pong ball, 3I Atlas would be the size of a multi-story building. And that's a massive problem. Objects that big shouldn't appear once per decade. Based on the amount of rocky material drifting between stars, the ejection rates from planetary systems, the density of interstellar space, something this massive should show up once every 10,000 years or more. Maybe once every 100,000 years. Not now. Not conveniently when we happen to have telescopes capable of detecting it and spacecraft positioned to photograph it. The math doesn't work unless one of two things is true. Either the object isn't solid rock and is somehow much bigger than its brightness suggests, or it's not following random statistics. Loeb writes a paper. He shows his calculations step by step. He explains the statistical paradox clearly. It's careful, peer-reviewed, professional. And at the end, he adds one sentence exploring the second possibility. One sentence suggesting that if the object was deliberately aimed at the inner solar system, that would resolve the statistical impossibility. Not claiming it's true, just noting it as one hypothesis that fits the data. The journal editor, Chris Lintott from the UK, responds immediately, remove that sentence or we won't publish. Not, can you provide more supporting evidence? Not, explain your reasoning more clearly. Not, address these counter arguments. Just delete it, censor it, don't say it. Loeb removes the sentence to get the paper published. Information needs to get out. Then he immediately writes an entire separate paper exploring that one deleted sentence in detail. If they won't let him mention it, he'll write a whole analysis of it. Lintott finds out about the new paper, goes to the New York Post, publicly declares that anything other than a natural comet is nonsense on stilts. This is the same man who, as editor of an astrophysics journal, decides what scientists are and aren't allowed to publish, what conclusions are acceptable in scientific literature, what questions can be asked publicly. That's when the pattern started, the mockery, the control. But 3I Atlas kept refusing to cooperate. The object started doing things comets don't do. July 21st. Hubble captures a jet pointing toward the Sunday. Comets don't do that. Heat vaporizes ice. Solar wind pushes material away. Always. It's basic physics. 3i Atlas had an anti-tail pointing the wrong direction. And those October 2nd images could show us exactly what that jet is. The sideways view, the structure, whether it's natural or engineered. Then, composition came back wrong. Two teams announced water-rich. Brian Cox agreed publicly. Webb telescope proved them wrong. 87% carbon dioxide, 9% carbon monoxide, 4% water. Not water-rich. Water poor. Comets are supposed to be mostly water. This challenges what a comet even is. Did Cox correct himself? No. He moved on. Because maintaining authority matters more than being right. Let me show you how improbable this object is. Anomaly 1. Trajectory aligned within 5 degrees of the ecliptic plane. Probability, 0.2%. Random objects should come from random angles. Oumuamua and Borisov came in steep. 3i Atlas threaded through where the planets orbit. 1 in 500 chance. Anomaly 2. Anti-tail pointing toward the Sunday unprecedented. Breaks fundamental physics of how comets behave. Anomaly 3. Size and speed. 1,000,000 times more massive than Oumuamua, 1,000 times bigger than Borisov, but also faster than both. In nature, bigger means slower. Probability, less than 0.1%. Anomaly 4, perfect timing. Passed within tens of millions of kilometers of Mars. 10 November, Venus, November 3rd, and Jupiter, March 16th. 2026. 3 perfect planetary flybys for spacecraft orbiting those planets to photograph it up close, while simultaneously becoming completely invisible from Earth during perihelion on October 29th. Hidden behind the sun from our perspective. The most critical moment, when it's closest to the sun, potentially undergoing changes, potentially doing something, is important. It was perfectly concealed from every ground-based telescope on Earth, from every amateur astronomer, from every space telescope in Earth orbit. The only views were from spacecraft around other planets and from solar observatories that stare at the sun constantly. Think about the improbability. The object had to arrive at exactly the right time to thread through the inner solar system, when Mars, Venus, and Jupiter were all positioned for close flybys, while Earth was positioned on the exact opposite side of the sun during perihelion. Imagine throwing 3 darts simultaneously and hitting 3 different bullseyes across a room, while a 4th person standing nearby turns their back at the exact moment you release. The timing has to be perfect. The angles have to be exact. The coordination has to be impossible. Probability, 0.005%, 5 in 100,000. Loeb was asked about this in an interview. Why would it do that? Why would the timing be so perfect? His answer was measured, but unmistakable. One possibility is that it wants to avoid us from seeing it. Anomaly 5, industrial composition. Way more nickel than iron. Natural comets have equal amounts. 3i Atlas has industrial ratios, the kind we make for aerospace using the carbonyl pathway, a chemical process we invented. Elon Musk addressed this on Joe Rogan's podcast just days ago.
Also because it's made almost entirely of nickel, whatever it is. And
Yeah.
the only way that exists here is industrial alloys, apparently.
There are definitely comets and asteroids that are made primarily of nickel. In fact,
Really?
Yeah. So the places where you mine nickel on Earth is actually where there was an asteroid or comet that hit Earth that was a nickel-rich,
Wow, and it left a giant nickel-rich deposit?
Yeah, it's coming. Those are from impacts. So you definitely didn't want to be there at the time because anything would have been obliterated.
Right.
But that's where the sources of nickel and cobalt are these days.
So this is Avi Loeb. A few hours ago, the first hint of non-gravitational acceleration, that something other than gravity is affecting its acceleration, meaning something is affecting its trajectory beyond gravity, was indicated. Interesting. Dun, dun, dun. So it's mostly nickel, very little iron, which he was saying is on Earth, it only exists in alloys. But whatever, you're dealing with another planet.
There are cases where there's very nickel-rich asteroids, meteorites that have it.
He suggested natural asteroids can be rich in nickel. But here's what he missed. Those asteroids are also rich in iron. The anomaly isn't just nickel. It's the ratio. High nickel compared to iron. That's the signature of industrial production. Anomaly 6, 4% water. Comets are dirty snowballs, mostly water ice. Finding one that's 96% other material is like finding an iceberg made of rock. Anomaly 7, extreme polarization, light twisting in ways no known natural material does. Not even Borisov, which we know is natural. Anomaly 8, wow signal direction. August 15, 1997. The famous radio signal. Never repeated. 48 years of mystery. 3I Atlas came from the same direction, within 9 degrees. Probability, 0.6%. And Loeb revealed, I encouraged radio observers to study it. They told me 2 days ago they're on target. Radio telescopes are listening right now. Anomaly 9, impossible blue brightness. October 29th, hidden behind the sun from Earth. But space observatories watched it get bright, impossibly bright. And it turned blue, bluer than the sun itself. For an object to appear bluer than the sun, it needs to be hotter than the sun's surface. The sun is 5,800 degrees Kelvin. 3I Atlas should be a few hundred degrees based on distance. For the color we're seeing, above 6,000 degrees. Loeb's explanation, maybe there is some power supply. It could potentially be explained by a hot engine or a source of artificial light. 9 anomalies, each one improbable. Together, nearly impossible. All the same object. Then ALMA detected the potential 10th, October 29th. 3. I-Atlas was 4, arc seconds off its predicted position. Non-gravitational acceleration, something pushed it. For natural outgassing to cause that, the object would need to lose 15% of its mass, more than 5 billion tons. That forms a massive visible debris cloud. December 19th, 43 days from now, 3I Atlas passes closest to Earth. If that debris cloud exists, it will be impossible to miss. But here's what Loeb just revealed in an article published hours ago. Post-perihelion images do not show evidence for it so far. No debris cloud detected yet. The object accelerated. But there's no visible sign of the 5 billion tons of material that should be there. If this holds through December, we have the 10th anomaly, an object that accelerates without losing mass, something that violates comet physics, or something that isn't a comet at all. And to understand the scale of what we're dealing with, 3I Atlas has similar mass to the Chicxulub impactor. The asteroid that killed the dinosaurs 66 million years ago. Loeb wrote, its absence would add a 10th anomaly to the growing list. That absence might already be real, and those October 2nd high-rise images could help us understand what happened, could show structure that explains the acceleration, could reveal what we're looking at. The image is being withheld for 33 days. November 2nd, Avi Loeb finally lost it. Interview about NASA, about the data, about the shutdown excuse. I don't think there is anything indicating extraterrestrial intelligence in the data being withheld. I think it's the result of terrestrial stupidity. Terrestrial stupidity, not aliens, not cover-ups, just bureaucracy and politics. Using politics to prevent the flow of information, the sharing of information among scientists that should not be delayed by any political agenda. The excuse is government shutdown, but the principal investigator isn't a NASA employee. Dr. McEwen is a University of Arizona professor. The shutdown doesn't affect him. The data exists. Someone chose to withhold it. It's completely inappropriate to withhold data from the scientific community. This is time-sensitive data. We would design our future observations based on what we know. Withholding it can hinder our expectations. Completely inappropriate. Fighting words in academic language. 33 days withheld. A celebrity got answered in 11 minutes. A congresswoman's official letter got ignored entirely. A Harvard scientist who's published 11 papers on this object can't get a response. Subscribe, because the 10th anomaly might already be confirmed. We'll know for certain by December 19th. We'll know if Loeb was right to lose his patience. We'll know if those October 2nd images were worth hiding, or if NASA just had more important priorities than answering Congress and scientists, like responding to Kim Kardashian in 11 minutes.